All right, looking at conic parabolas today. I'm just going to pull out my green paper from earlier in the week just to kind of look at what their formula looks like. Conic parabolas can actually face 4 different directions. They can face either up or down. Okay, that would be a vertical parabola. Verticals can face up or down. They can also face sideways, horizontally, either left or right. So just thinking about how I remember which way it's going to face, starting with just the vertical parabola, it's normal for a parabola to face up or down. Okay, we've been doing up and down parabolas since Algebra 1, and that happens whenever the x term is squared, which again is normal. If you think about a normal, like standard form quadratic, I'll remind you what that looks like. Normal standard form quadratic is something like ax squared plus bx plus c equals y. So it's normal for x to be squared. So anytime I see x is squared, I'm like, oh, okay, this is going to face up or down just like they normally do. Opposite of that, horizontal parabolas, well, the ones that face sideways, this is going to happen when the y term is squared. That's different. We don't normally have the y term squared. So that's how I think about it. Oh, okay, when y is squared, that's different. Y is not normally squared, which is going to cause it to be a sideways facing parabola. In the equation right here, this number that's the coefficient in front of the unsquared term, based on this sign, you can tell whether which way it's going to face. So if it's a vertical parabola and that sign is positive, it's going to face up. If that sign is negative, it's going to face down. If it's a horizontal parabola, a sideways one, based on this sign, you can figure out which way it faces. If it's positive, it's going to face towards the right. If it's negative, it faces towards the left. So on each of these, they have lots of things. They have, instead of a center, they have a vertex, just one vertex. That vertex is at like the lowest point here, at the leftmost point here. That vertex is at HK, just like we're used to. Inside the cup of the parabola is one focus. So actually I didn't label it on here. So right here would be the focus. I'll put a little label. That's the focus. So just one focus, unlike hyperbolas and ellipses that had 2 foci. The focus on this one is right here. There's also 2 lines that are part of parabolas. The first line is called an axis of symmetry. We're used to axis of symmetry. We've heard of those before. The axis of symmetry is going to cut down through the focus and the vertex, basically splitting the parabola through the middle. So on this one, on a sideways parabola, your axis of symmetry is going to be a horizontal line going through the vertex and the focus. The second line that's part of a parabola is what's called a directrix line. A directrix actually helps you, it's the part of the technical definition of a parabola. The directrix is actually perpendicular to the axis of symmetry. So on this sideways one, if your axis of symmetry was horizontal, the directrix will be vertical. So if we go look back at that technical definition of a parabola, it's the set of all points in a plane that are equidistant between a fixed point. That fixed point is called the focus, and some sort of line, and that line is called a directrix. What else? Both the focus and the directrix are p units away from the vertex. So you can see the focus is p units up, the directrix is p units behind, and p again is part of the equation. It's basically a fourth of whatever number is right here. You can see on a sideways parabola, the focus is p units to the right inside the cup. The directrix is p units behind. I know it's a lot of information right now. And then lastly, figuring out how wide your parabola is based on this amount right here. I abbreviated it because it has a hilarious name. Anyone want to guess its name? What LR is abbreviation for? LR actually stands for latus rectum. Yeah, it's the booty of a parabola. How wide the booty is. Yeah. LR measures the absolute value of 4p all the way across. So like if 4p is negative, you just have to think about it without its sign. So all the way across, the lattice rectangle would measure exactly what your 4p number is. So all the way across here should measure exactly what my 4p number is. I'll put a little reminder here. Lattice rectum, the width of the booty. Okay. So looking at what the standard form looks like again for a parabola, parabolas only have one squared term. So anytime we have to complete the square, we only have to do it once. That's kind of nice. One squared term. The squared term I see over here is isolated. The squared term on this one is isolated. All the other terms are on the other side, and then the leading coefficient is pulled out. All the other terms on the other side, leading coefficient is pulled out as coefficient. Let's try one. For this first one here, to put it in standard form, I need to start by just isolating the squared term. Squared term's not isolated yet. What could I do to isolate the squared term? Multiply by 8. Yes, times 8 times 8. For some reason, I prefer my squared term to be on the left side, so I'm going to write it on the left. Don't need that. So I'm going to have x squared on one side. And on the other side, I'm going to have that 8 times y. Now, this is technically in standard form. I know it doesn't look like it, and the reason it doesn't look like it is because your h and k are both 0. So if you were to write in the h and k, you would have x minus 0 squared equals 8 times y minus 0. And then you can definitely see your h is over here paired with the x. Your y is here paired with, your a. I wrote y, it should be k. Your k is over here paired with the y. Okay, now it's in standard form. So figuring out which way it opens. So first off, the x is the squared term. And remember, it's normal for x to be squared, which means this is going to be a normal either up or down parabola. And it's all based on the sign of this 4p number right here. If it's positive, if 4p is positive, it faces upwards. So I'm going to write that, opens up. So basically this one's going to look pretty dang normal. Okay, our vertex is going to be at HK, which is that pretty easy on this one. 0, 0. Okay. I'm going to go ahead and graph that vertex at 0, 0. Just like normal. Okay, so thinking about the focus and the directrix, okay, we have to find what's called the focal length. To do that, you're going to take 4p and set it equal to the absolute value of this number right here. Okay. Well, what is the absolute value of 8? Still 8. So 4p equals 8, which means p equals 2. Okay, so both my focus and my directrix are going to be 2 units away from this vertex. The focus, though, is 2 units up, basically inside the cup of this parabola. So I'm going to have a focus that's 2 units up. Labeling it with F. I'm going to have a directrix that's 2 units behind. Now, the directrix is not a point, but I'm going to put a point there temporarily just so we can think about it. So the axis of symmetry is going to cut down through the focus and the vertex, which means the directrix should be perpendicular to that, which means my directrix is actually going to be a horizontal line going right here. I'm going to graph that horizontal line as a dotted line because, like an axis of symmetry, it's just part of what helps you graph it, but not actually what helps you graph, but not the actual parabola. And then I can graph my axis of symmetry. My axis of symmetry is going to cut down right through the focus and the vertex. It's going to be a vertical line on this one. I'm going to label it AOS. We can write down what both of those are. What is the ordered pair of that focus? 0, 2. Okay. The equation of the directrix. It's a horizontal line, so it should be y equals, good. So it'll be y equals -2. The equation of the axis of symmetry, x equals 0. Very good, because it's a vertical line. They're part of how you would draw a very technical, precise one. Like, remember the other day when we saw an ellipse with the pins? They're part of the definition of a parabola. It's the set of all points that are equidistant between the focus and the directrix. So the focus and the directrix are part of the definition of it. And we kind of cheat and draw them in backwards instead of like actually, putting down pins and grabbing a string and swinging it around.
They don't actually mean anything.
They are. They're part of the definition. Yeah, they do mean things. Part of the definition.
Like a cardinals. Like I just don't see what we have.
It's like a piece of the graph. Like you need it. Just like we found the foci on the ellipse, they were part of the technical definition of it, so we need to include it.
That's just really weird. That's my only question. It's part of the technical.
Well, I don't make the shape, Danny. I don't. I didn't design the shape and included it. You're welcome to research that later and write me a 10-page paragraph about it. Okay. Last thing we actually need to do is draw the shape. Now, to draw the shape, we need to determine how wide it's going to be. And that is based on the length of the LR, the lattice rectum. It's going to measure 4p all the way across through the focus. 4p all the way across through the focus. So if this is my focus right here, I know it should measure 8 all the way across through the focus, which means how much in each direction? Or in each direction. So from the focus, I'll count 4 to the right, 4 to the left, and then that should be the ends of my lattice rectum. So now I have 3 points that are on this parabola. I have the vertex, I have the 2 ends, and I can use those to draw my parabola.
Is it curved?
Yes, it's a parabola. You've seen what parabola look like before. Is it curved? There's also one on the top of your paper. Okay. Dang, mine was almost perfect. All right, let's try the next one. Let's try and first get it in its perfect standard form. Standard form, again, has the squared term isolated. Squared term isolated. What will I need to do to isolate that squared term? Yep. Divided by 3. So I'm going to divide everything over here by 3. And remember, I like to have my squared term on the left. I don't know why. That's just how my brain thinks. So I'm going to write y squared equals, and then we'll have -4x minus 2. Now, this is not quite beautiful little standard form because standard form has the leading coefficient on the right side pulled out in front. What is the leading coefficient? -4. So I need to pull that out in front. If I take this -2 and divide it by that -4, what am I going to get? Plus, what?
That's good.
No, 2 divided by -4 is not 2.
What?
It's a half. Yes. If I wrote my K number on the right side, what is my K number?
Oh, 5 minus.
Right, it would technically be 0. All right, now it's in beautiful little standard form. H, remember, is always paired with your X, so this one would be my H. K is always paired with your Y, so this one would be my K. Figuring out which way it faces. So first off, I can see the y is squared. That's not normal on a quadratic for y to be squared. So I know that this is going to be one of the weird ones that faces sideways. And based on this sign right here, we can tell whether it faces sideways left or sideways right. Which is it going to be? Sideways left. Yep. It's going to face left. which means we'll have a vertex right at the rightmost point of it. We'll have our focus inside the cup of the parabola, and we'll have our directrix behind it right here when we think about what it's going to look like when it's correct. So starting with the vertex, the HK vertex. For the H, remember we have to write that down with opposite signs, so what are we going to write?
Versus negative 1/2 inches.
Good. Negative 1/2, 0. Okay, I'm going to go ahead and graph that vertex at negative 1/2, 0. Okay, to find my focus and my directrix, I'm going to need to use my focal length. Focal length is based on your 4p number.
4p equals negative
4p equals the absolute value of negative 4. What is the absolute value of negative 4? 4. So just 4p equal, that means p equals 1. So my focal length is 1, which means my vertex, if this is a left-facing parabola, my vertex should be 1 unit to the left of the vertex, and my directrix should be 1 unit behind the vertex. So it's all based on this 4p number. So I'm going to graph my focus 1 unit to the left, label it. I'll graph my directrix, which is 1 unit behind. Okay, but remember, the directrix is not a line. I mean, the directrix is not a point. It's an actual line that's going to be perpendicular to the axis of symmetry. So thinking about my axis of symmetry is going to be a horizontal line going through the focus and the vertex. I'm going to go ahead and graph that. This one's my axis of symmetry. Okay. My directrix then will be perpendicular to this line, but again, 1 unit behind the vertex.
I like the
Is that the what?
Look,
Okay, so I can write down some information now. What is that ordered pair of that focus?
Oh, negative 1 or
negative 1/2.
Yeah, negative 1.5, 0, negative 3 over 2, 0. Okay, the directrix on this one is actually a vertical line. What would be the equation of that vertical directrix?
X equals 1/2.
Mm-hmm. And then the axis of symmetry on this one is very good. It's a horizontal line, which would be y equals 0. And then last thing is to actually draw the parabola in, and we need the length of the latus rectum, the LR, to do that. Okay, so the LR is going to measure the absolute value of 4p all the way across. So the absolute value of 4p is basically just, so through my focus, it should measure 4 all the way across. So so if it measures 4 all the way across, that would mean 2 up and 2 down through the focus. 2 up, 2 down, because it should measure 4 all the way across. And then that creates 3 points that you can use to graph your parabola. 1 is the vertex, 2 are the ends of the LR. And remember, this one faces left. I usually try and not make these like super large, like I don't continue and draw a whole entire shape because it starts getting a little wonky looking. Bless you. Bless you. Bless you. All right, let's flip it over. What we got? Okay. Almost in standard form. But again, standard form, the squared term is isolated all by itself. Okay, so to get that squared term isolated, I'm going to have to do 2 things. I'm going to have to start by adding x to both sides. And then that gives me 1/8 times y minus 4 squared equals 0 plus x, which would be just x. And then one last thing to get the squared term all by itself, multiply by 8. So that gives me, let's see, y minus 4 squared equals 8 times x. What would be the h that's paired with this x 0? So if you want to, you can write 8 times x minus 0 to help you really see that that h is 0. Because remember, h is always paired with the x and k is always paired with the y. So thinking about which way it opens. So starting with just the fact that y is squared. It's not normal for y to be squared on a quadratic, which means this is going to be a sideways facing one. It faces right because it's positive. Very good. Our 4p number here is positive, which means we're going to face right. So thinking about what it's going to look like if it faces right, it's going to have a vertex at the leftmost place on it. It'll have a focus inside the little cup of the parabola, and it'll have a directrix behind it, to the left of it, basically. My HK vertex, what's that going to be at? 0, 4. Very good. So I'm going to graph that vertex at 0, 4, 2, 3, 4, 2, 3, 4, 8. I'm going to label that with vertex. To find where my focus and my directrix are, that is based on the focal length, which is P. So in front of the x term is 4p, so we'll say, well, the 4p equals 8. What does p equal? 2. So my focal length should be 2, which means if this faces right, my focus should be 2 units to the right of the vertex. My directrix should be 2 units to the left of the vertex. So my focus is going to be 2 units to the right. My directrix will be 2 units to the left. Remember, directrix is not a dot, it's an actual line. I just have to figure out how to draw that line. That's what I've been using. So the axis of symmetry on this one, the axis of symmetry should go down through the focus and the vertex. I'm going to draw in that axis of symmetry. Okay, which means the directrix, that point that I put that's 2 units to the left of the vertex, that should be perpendicular to the axis of symmetry. So that should be a vertical line directrix. So what ordered pair is that focus at? 2, 4. Okay, the directrix on this one is a vertical line, which is going to be x equals -2. Okay. The axis of symmetry for this one is a horizontal line at y equals 4. And then lastly, we need to figure out how wide it's going to be. So looking at my 4p number, this 8 right here should be how wide it is through the focus, that lattice rectum length, the LR. So that's telling me that all the way across through this focus, it should be 8 units in total. So that means 4 up and 4 down in that focus. 1, 2, 3, 4. 1, 2, 3, 4. Which gives us 3 points that we can use to graph this right-facing parabola. Beautiful. Okay. One last one that we have to graph. If you look at this one, I can see my square term as the x, but then there's also another x that's not squared that's partnered with it. That is kind of telling me that I am going to need to complete the square for this little group here so that I can get it as just one x plus or minus some number term. So remembering our steps for completing the square, I'm going to isolate the square term along with its mate, which would be the 2x terms, which means I need to move this y and this -1 to the other side. So that would give me a negative y on the other side and a positive 1 on the other side. Okay. And now we can find our number to complete this square. We'll take our b term, which is negative 2. We'll divide that by 2 and square it, which would be negative 1 squared, which is 1. Is 1 what I add to the other side? Yes, because there was no leading coefficient, so we do want to add 1 to the other side as well. So this parenthesis should be a perfect square now, which means it'll have 2 matching factors. And if it has 2 matching factors, then you can just write it as 1 factor squared. What is that 1 factor? X minus 1. And then the right-hand side is going to simplify to negative y plus 2. Now the right-hand side's not quite perfect yet because we do need to factor out the leading coefficient, which is basically just a negative 1 on this one. Yeah. So if I take out that leading coefficient, that would leave me with a y minus 2. This one's going to be fun to graph. Do y'all see why it's going to be fun to graph? Our 4p number is really small. All right. First, figuring out which way it opens. The x is squared. It's normal for x to be squared on a quadratic, so it's telling me it's either an up or a down one. Up or down? Which one is it? Down, because the 4p number is negative, right? Okay, so downwards, you'll have a vertex at the top. You'll have a focus below that inside the cup of the parabola, and you'll have a directrix that's behind it, kind of perpendicular to the axis of symmetry. Thinking about my HK vertex, I can see H is over here paired with the X. K is paired with the Y. I need to write them down with opposite signs. What's my vertex going to be at then? 1, 2. Very good. Okay, so I'm going to graph that vertex at 1, 2. Okay. And then to find my focus of my directrix, I need the focal length. Focal length, basically you take 4p, because this is equal to 4p. So you take 4p, you set it equal to the absolute value of that number. So 4p equals 1, which means p equals 1 over 4, or else so teeny tiny. So if this faces downwards, that means I'm going to have a focus that is 1/4 of a unit below the vertex. And I'll have a directrix that's 1/4 of a unit above it. So my focus will be 1/4 below. My directrix will be 1/4 behind. The axis of symmetry is going to cut down the middle of that vertex in focus. The directrix will then be perpendicular to that axis of symmetry. So the directrix is right here. Hard to graph a 4th. I should have adjusted the scale. All right, figuring out what those numbers are now. Starting with my focus. We were at 2 and we went down a 4th. What are we at now? We are at 2 and we went down a 4th. 1.75, right. So that point would be 1.75. My directrix, again, it was 1/4 of a unit above the vertex. So if we were at 2 and we went up a 4th, what number would that be? We were at 2 and we went up a 4th. 2 plus a 4th is 2 and 1/4. Yeah, 2.25. It is a horizontal line though, so we'll need to write y equals 2.25, 2 1/4. Axis of symmetry is pretty easy to write on this one. It's a vertical line, so we're going to write x equals what number? 1. And then lastly, just drawing in the ends of the lattice rectum so we know how wide it is. So looking at it, it should be exactly what the absolute value of your 4p number is, which looking at this, that's telling me that it should be 1 unit wide. 1 unit wide. So through the focus, it should be 1 unit wide. So which means we need to go a half a unit in each direction. Half here, half here. Give it a little doodle. So cute. Is y'all that adorable? No. All right, and then one last one. Again, we've done ones like this on every notes. We're just working backwards to put the shape together. I usually include a graph on these just kind of because it helps to visualize it, not because you actually need to fully graph it. So it has a vertex at 3, 1. There's a focus at 3, 5. 3, 1, 2, 3, 4, 5. Can we tell which way it faces? Which way? Yeah, it faces up. Because the focus has to be inside the cup of the parabola. Faces up. Which tells me which is the squared term if it faces up. Yep. X is squared. It also tells me that my 4p number should be positive, not negative. Okay, so if I'm slowly trying to put this together, I know my x is going to be the squared term. I'm going to have some sort of 4p number here, and I'm going to have y as my not squared term. Yeah, you already know your HK. You're actually given the HK. Right here is your HK. So you'll have x minus 3 and y minus 1. And then lastly, just figuring out our focal length number 4p to go here. You can count this number right here. 1, 2, 3, 4. That has a distance of 4 up. So this should be 4 times 4, 16. Because this should be just what p is. That's it. That's the whole equation. And we knew it was positive because it faces up.